So we're going to review how to use substitution and elimination to solve systems algebraically. The first one we've got is great for substitution because y is all by itself here. So this entire thing is equal to y. So we're going to replace that into the first equation where y is. So we're going to take 2x minus 3, take out the y, and make it 3x plus 20 in its place, equaling 10. This makes an equation with only x's in it that we can solve. So just take the negative 3 and multiply it in. So negative 3 times 3x is negative 9x. Negative 3 times 20 would be negative 60. Bring down everything else, and then just solve this equation from here. That would be negative 7x when combining like terms, minus 60 equals 10. Add the 60 over, and we get 70 equals negative 7x. Dividing by negative 7 gets you x equals negative 10. For our y value, we can use either equation that we have originally and put our answer of x in for y. I'm going to use the second one because it's a y equals equation, so getting y is pretty easy. Y equals 3 times the x plus 20. So the x goes in here, negative 10. So negative 30 plus 20 is negative 10 as well. So both coordinates, both parts of the coordinate are negative 10. That doesn't always happen, but in this case, both are negative 10. So down below, you've got 4 examples that you can complete that are just more substitution practice. Look for the variable that's by itself. So like in this case, y is equal to this. So very similar to the first one, substitute that in. The next one has x by itself. So this goes in for x this time, not y. And 3 and 4 are very similar. 4 always kind of like tricks people up a little bit. So they're both equal to y, which means you can do it either way. You can put this part here, which equals y, in for y in the second one, or you could take this one and put it in for y in the first one. It doesn't matter. It makes basically the same equation, just flipped around. Let's now review elimination, which is on the back of your worksheet. So flip over and take notes with me. So for elimination, you want to always make opposites. So you want to have either opposites with the x's or with the y's. So it doesn't matter which one you do. You have to kind of pick whatever one you think looks easier to do. So looking at these, I see the negative y all by itself. That's pretty easy to change into a negative 3y to be an opposite with these 3y down here. Or we could say, well, this is 3x and this is negative 6x. I could make this positive 6x pretty easily with an opposite in the bottom. So it doesn't matter how you do it. Either way, you'll get the same answer. Just pick whatever way you think is easier. I think I'm going to actually do the top one times 2, just to make it a little bit easier, not having to worry about the negative. That would be 6x minus 2y equals negative 6. Copying the second one exactly looks like this. And then when we do our elimination, when we have opposites, we just simply add them. The x's will be eliminated, and you'll get positive 1y equals negative 6, which was actually pretty quick. That was nice that we got right to y. So now we're going to find x. Using either original equation, we're going to take our answer and plug back in and get x. You're going to have to pick whatever one you think is easier. I think I'm going to do, I don't know, maybe the bottom one. There's no negative on the y. It might be a little bit easier there. So negative 6x plus 3 times the y equals 0. Solve this two-step once you just multiply. Solve that for x. Add 18. So 18 equals negative 6x. And x equals that division, which is negative 3. So there's our answer. Always write it as a coordinate, negative 3, negative 6, because it's always x followed by y. So down below, you'll see 4 examples of elimination. Always make an opposite first by multiplying at least one of them by something if needed, and then add them to eliminate a variable, and then take your answer and plug back in to find the other variable. You always want to find an xy solution.